In this video, we're going to be working on finding angle measures using trig or using SOHCAHTOA. So the first thing I'm going to do is I'm going to write down SOHCAHTOA up at the top of this page. Remember, that was sine, cosine, and tangent. And then the other thing I want to talk about before we get into this is how we're going to be solving these equations, because the equations we're going to end up writing are going to look something like sine of x, or sine, sometimes we'll put theta there as well. You'll see your teachers do that. But since the angle is the thing we won't know, that's where the variable is going to go. So we're going to say sine of this angle is equal to, say, 3 over 5. So the difference here, where we normally have had a number here and then the variable on this side, now the variable is on this side. In order to get the variable by itself, we're going to have to get rid of sine. That's where we're going to have to use sine inverse, cosine inverse, or tangent inverse. And these are called inverses because they're like inverse operations or opposite operations. So to undo sine, we're going to use sine inverse. Just like division and multiplication undo each other, sine and sine inverse will undo each other to get x by itself. So we take sine inverse of whatever's on this right side, since we're doing it to both sides to get x alone. Now you need to know where that button is in your calculator. If you look on a regular scientific calculator, you'll see right above where we have our normal sine button, there's sine to the -1 exponent. That means sine inverse. And then right above cosine is cosine inverse, right above tangent is tangent inverse. To get to those commands, you have to press the second key. So I press second, sine inverse, and then it uses the inverse version of sine. All right, so let's try a couple problems like this together. So this first problem I'm going to do, I've got a right triangle. The side down here at the bottom is 15, hypotenuse is 24, and then the angle I'm looking for up here is x. First thing I need to do is know which trig function I should use, sine, cosine, or tangent. So again, just like in these last few examples, we're going to base that on how these sides relate to this angle. This side here, 24, I've already said is the hypotenuse. This side across from x, that's going to be the opposite side from this angle, since this is the one I care about. And the side that I don't know anything about, that would be my adjacent side, but I'm not using that one. So since I have opposite and hypotenuse, that tells me I want to use sine for this first part of SOHCAHTOA. So I'm going to set up my equation. Remember, it's always sine of an angle equals opposite over hypotenuse. Well, in this case, sine of an angle, I don't know the angle. So I'm going to say sine of x equals opposite, 15, over hypotenuse, 24. All right, this is what we were talking about that we were going to end up at. I've got the variable here with sine. I need to undo sine. So I'm going to write this as x equals sine inverse of 15 over 24. I take my ratio, and that's what I'm going to be taking the sine inverse of. Really, I'm taking it of both sides. We're just kind of assuming those two cancel, and we're kind of having that step happen invisibly. All right, so I go to my calculator. Second, sine inverse. So I hit the sine button after I hit second, and then I type 15 over 24. And I should get to this answer. Now, if you did not get to this answer, check to make sure your calculator is in degrees. And I'll do that again so I can see it again. All right, and then that's the answer I should get. We're going to round, just like we've been, to 1 decimal place. So I'm going to look at the second decimal place. That's an 8. That tells me to bump up my 6. So I'm going to say x is 38 point, and I said bump it up. 6 bumps up to 7, 38.7 degrees. All right, example 2, I've got a right triangle. I've got x down here in the corner. Bottom side is 11. This side is 8. All right, what sides do I have? Well, across from my right angle, that's 11. That makes this the hypotenuse. This side, is this the opposite or is this the adjacent side? Well, x is here. This is my angle. This side would be opposite because it's across. This side would be adjacent. Adjacent and hypotenuse, what do those make? If I look back at SOHCAHTOA, adjacent and hypotenuse make cosine. So I'm going to be using cosine. So cosine of my angle, x, equals adjacent, 8, over hypotenuse, 11. All right, once again, I need to do cosine inverse of this fraction, 8 over 11. How do I get to cosine inverse? Second cosine. And then I have cosine inverse typed in. 8 divided by 11 equals that. There it goes. What should I round to? Well, 3 is the one that I'm going to keep, or bump it up if I have something 5 or more here. This is just 4, so I don't bump it up. It just stays 43.3. Last but not least, I've got a right triangle here. This side's 20, this side's 37, and this side here I don't know. This is where my angle is. All right, this side here, this is the one across from the right angle. That's my hypotenuse. I don't know it, so I'm not using my hypotenuse in this problem. 20 is across from x. What would that make 20? Well, 20 would be my opposite side. 37, that's the side I can reach out and touch, because this was my hypotenuse, which I don't know. This would be my adjacent side. So I have opposite and adjacent that I'm using here. What do opposite and adjacent make for SOHCAHTOA? Opposite and adjacent would be tangent. So I'm going to do tangent of my angle equals opposite 20 over adjacent 37. I need to get rid of tangent, so I'm going to do tangent inverse of 20 over 37. That's what x is equal to. Tangent is second tangent button. 20 divided by 37. That's what I get. How should I round this? What does the 9 do to the 3? Well, the 9 is bigger than 5 or more, so I add 1 more. I bump that up to 4. So 28.4 degrees. And there are our 3 examples.